Okay. That brings us to the quantum mechanical model, which Heisenberg, with his uncertainty principle, the uncertainty principle says you can't precisely know an electron's position and velocity. De Broglie, which was his particles have wave behavior. The quantum mechanical model says we don't know the specific electron positions. We just know a probability. So everything was figured out for hydrogen first, and then the model applied to see if it worked on others. That's why Bohr's model fell apart, because it didn't work for anything other than hydrogen. So this is interesting, that for hydrogen, the most probable distance does correspond to Bohr's orbital. But the size of any orbital is where there's a 90% probability of finding the electron. So now let's talk about quantum numbers. We have the principal quantum number, which is the energy of the orbital. So to use the Bohr model as a picture, that would be our principal quantum number. Then we have an angular momentum quantum number, which is L, and that goes from whole integers 0 to n minus 1. And this is related to the shape of the orbital, and we use these sublevel designations. Now let's jump to a periodic table. Sorry about this. There we go. Our principal quantum number corresponds to the period or the row on the periodic table. Our L's and those sublevel designations S, P, D, and F correspond to regions on the periodic table. Okay. The magnetic quantum number, m sub L, or sometimes just m, is integers from negative L to L. And we do include 0. And this is going to give us the number of orbitals in a sublevel. And then our last quantum number, spin, is m sub s, or sometimes just s. And all that can be is plus 1/2 or minus 1/2, which this is going to tell us that we're only allowed 2 electrons in an orbital. So if we have n equals 4, then what L's can we have? We can have 0, 1, 2, and 3. So what m sub L could we have? Well, for 0, all we can have is 0. And for the s, that's all we have is 1 orbital. For L is 1, our m sub L can be -1, it can be 0, it can be 1. And for the p sublevel, we have 3 orbitals. For L equals 2, we could have -2, -1, 0, +1, or 2. The D, we can have 5 orbitals. For L equals 3, we can have -3, -2, -1, 0, 1, 2, and 3. 1, 2, 3, 4, 5, 6, 7. For an F sublevel, we have 7 orbitals. And since through our m sub s we learned that there are 2 electrons per orbital, that means we can have a maximum of 2 electrons, 6 electrons, 10 electrons, and 14 electrons. Okay? Check those regions on the periodic table, and you'll see that's exactly the number of columns in each section.